Yes, we will go for the next numerical. Draw pole zero plot for I0 divided by I1. So I0 is here. I0. I1 is given. Okay, this is the current source. So this is a circuit given. So what we will do, this is the time domain circuits. First we will convert it into frequency domain. So in frequency domain, inductor will be in time domain inductor. So this is time domain. Okay, and this is frequency domain. So inductor in frequency domain is written as L into S, and capacitor in time domain is written in frequency domain as 1 by CS. Okay, so we are writing 4 as it is. Okay, resistance will remain same, and inductor 2 as 2S, and capacitor is half. So 1 divided by half is 2. Okay, so 2 by S. So this is called as transformed network. This is called as transformed network. Using current divider rule. The current divider rule. So the current divider rule, what is telling you, the I0 current, which we need to find out, is equal to the main current, which is the I1, that is a total current, okay, into the resistance of the other branch. Resistance of the other branch is 4 plus 2S, okay, divided by the total resistance. Divided by total resistance is divided by 4 plus 2S plus 2 divided by S. Okay, so the current divider rule is branch current is equal to the total current into the resistance of the other branch divided by the total resistance. So from here I will get I0 divided by I1 as 4 plus 2S into S divided by 2S square plus 4S plus 2. So here if I take 2S, okay, 2S I'm taking it common. So in the numerator it is S plus 2 is remaining. And in denominator, if I take 2 common, S square plus 2S plus 1 is remaining. So this 2 gets cancelled. The remaining in the numerator is S into S plus 2. And in denominator is S plus 1 whole square. So numerator, we get the zeros. Okay, from numerator, we get the zeros. Okay, and from denominator, we get the poles. Zeros are represented as 0 like this. Okay, so this is the 0 which is we have represented, and poles are represented as. So from this equation, from the numerator, S zeros are at S is equal to 0 and S is equal to -2, and poles are at S is equal to -1, -1. So 2 poles are there in the S is equal to -1 position. I have indicated with 2 colors. Okay, and zeros are at 0 as well as -2. So this completes the numeric. Next numerical, find the network functions Vi divided by I1, V2 divided by I1, and V2 divided by V1 for the network shown. So this is the network which is given. Okay, so this is the network which is given in the question. So here this is again a time domain. Time domain it is given in. So we will convert it into frequency domain, which is called as transformed network. Okay, so inductance is replaced by again inductance in time domain we will replace to frequency domain. Inductance in time domain can be replaced by Ls in frequency domain, and capacitor can be replaced by 1 by Cs in frequency domain. So you can see here this is 1 is replaced by S. Okay, 1 is replaced by S again, and 1 farad is replaced by 1 by S. 1 farad is replaced by 1 by S. So we will call this point to be as VB, and this point to be as VA, and let this current, okay, so this current be I. So from the network you can see V2 is the voltage across these two terminals. So this is equivalent to V. Okay, so this is equivalent to V. So this we are getting the equation 1. And IB is what? IB is the current through this capacitor. Okay, so the current through this capacitor is the value of IB, which is given as V2 divided by the impedance, that is 1 by S. So we get S into V2 as IB. Then VA, okay, to calculate VA is the voltage across, is a voltage across these two terminals. So it can be a sum of voltages at this inductor and the sum of voltages at this capacitor. So it is given as S into IB, okay, inductor across this we have taken, plus across the capacitor we have a voltage V, which is equal to V. Okay, so that I have put. So simplifying it by putting the value of IB as S into V2, so we get VA is equal to S square plus 1 into V2. Okay, so now we will calculate what is the value of I1. I1 is what? I1 is the current at this point. I1 is the current here. So this current is dividing between these two branches. So here the current is IB, which is going, okay, so this is IB. And the current which is going here, it is VA divided by 1 by S. Okay, so this is 1 by S. VA divided by 1 by S. Right? So VA divided by 1 by S will give you S into VA. Okay, then the IB I have written the same. Now we will substitute the value of VA and IB and then simplify it. So we get SQ plus 2S into V2. Now the total value of V1. Okay, so V1 you need to calculate. V1 is what? So you apply KVL at this loop. V1 is equal to I1 into S plus VA. Okay, so I1 into S plus VA. So VA and I1 value we are going to substitute and simplify. So we get S raised to 4 after simplification, S raised to 4 plus 3S square plus 1 into V2. So in the question they have asked to calculate what is the value of V1 by I1. Okay, V1 by I1, V2 by I1 and V2 by I1. So first we will calculate V1 by I1. Okay, so V1 is this value. Okay, and I1 is this value. Okay, this is the value of I1 and this is the value of V1. So this we will substitute. Okay, and V2 gets cancelled. So finally we will arrive at this. Similarly, V2 by V1 will give me the value 1 divided by S raised to 4 plus 3S square plus 1 and V2 by I1. Okay, so V2 by I1 will give me 1 divided by SQ plus 2S. So this completes the numerical.